Good morning, guys. So today we will discuss inequalities. So first of all, we will talk about linear inequalities, and then quadratic, and then rational inequality. So I will give you the first exam next week, Thursday. Okay? After 1 week from today. You see the week, I think the week before the last week, it was the campus was closed due to the bad weather, right? Inclement weather. So I just moved the exam from today to next week, okay? So next week, Thursday, I will give you first exam. Keep in mind, okay? And by the way, I posted the quiz, right? I assigned the quiz 1 in MyLab Math, right? And you can try that quiz, I think 5 times. Is that right? You can give a 5 try. And the highest score will be recorded in the grade book. Okay? So you can give 5 try. And you consider that quiz as a review for the first exam. Does that make sense? Okay. So let me tell something about linear inequalities. So if you have 3 real numbers A, B, and C, if you have 3 real numbers A, B, and C, if A is less than B, then what will happen? A plus C is also less than what? B plus C. If A is less than B, then A plus C is less than B plus C. Right? Or I can give you an example. If let's say if 3 is less than 4, right? Then you can add a number, let's say 7 on both sides. So 3 plus 7 and 4 plus 7. You see that? 3 is less than 4, and we add a number, 7 on both sides, right? So what is 3 plus 7? 10. What is 4 plus 7? 11. You see, 10 is also what? Less than 11. So this is one property. And the next one is, if A is less than B and C is a positive real number, the C is greater than 0, so that means C is positive, you can multiply both sides of the inequality by C without changing the inequality sign. So that is AC is less than what? BC. But this is true if C is positive. Did you get that? So for example, you say if you have 3 is less than 5, then you can pick any real number, but it should be positive. Positive, you can pick any positive real number. Let's say I want to pick 8, right? And I can multiply both sides, 8 times 3 and 8 times 5. And you know the 8 times 3 is 24, and 8 times 5 is 40. Yeah, 24 is less than 40. And the property number 3, you see, if A is less than B and if C is negative, if C is negative, this C is negative here. And if you multiply both sides by C, then what will happen? You have to reverse the inequality sign. You have to switch. What I'm saying here is, then AC is greater than BC. You see here less than, but here what did you see? Greater than. That makes sense? So now, for example, let's say 3 is less than 7. Let's pick a negative number, let's say negative 5. This is a negative real number, right? You multiply both sides. You multiply both sides of this inequality by negative 5. So you have a 3 times negative 5, and you have a 7 times negative 5, right? So what is 3 times negative 5? Negative 15, right? So this is negative 15, and what is 7 times negative 5? Negative 35. Now, which one is greater, negative 15 or negative 35? Negative 15. So negative 15 is greater than. You see that? You switch the inequality sign. So this is very important. If you multiply both sides of the inequality by a negative number, right, then you have to reverse the inequality sign. Make sense? So these three are important. And then if you replace, so these are the strict inequality. You see the less than, right? So these are the strict inequality. You can replace this by what? Non-strict. Same thing. Are you with me? Okay. So we want to solve the inequality, okay? Okay. So this is a linear inequality in one variable. You see, ax plus b is greater than 0. So this is a linear inequality in one variable. So ax plus b is greater or equal to 0, or ax plus b is greater than 0, or ax plus b is less than 0, or ax plus b is less than or equal to 0. These are the what? Linear inequality. Did you get it? Yes? It's simple. Like for example, if you have a, let's say, 3x plus 7 is greater or equal to 0, then how do you solve this? You isolate x, right? So that means you subtract both sides. Subtract 7 from both sides. You cross them out. So this is 3x is greater or equal to negative 7, right? Right? And you can divide both sides of the inequality. You have to isolate x. You did that, and you need to have a coefficient of x 1, right? So you just divide. It's pretty much similar to the what? Solving like a linear equation. Only thing you need to keep in your mind is if you multiply inequality by negative number on both sides, you reverse the inequality sign, okay? Or if you divide the inequality by a negative number, you also reverse the inequality sign. Does that make sense? That's the only difference. Okay? So now, so you want to make a coefficient of x1, so you divide both sides by 3. So you divide both sides by 3, and you cross them out. So it would be x is greater or equal to negative 7 over 3. So this is the what? Solution. So any number greater or equal to negative 7 over 3, including negative 7 over 3, because this is greater than or equal to, right, will satisfy the given inequality. Does that make sense? You have infinitely many values of x, right, that which satisfy this inequality. Any values equal to negative 7 over 3 or greater than negative 7 over 3 will satisfy this inequality. Make sense? Yeah. So far so good, guys? Good, good. Okay, so now let us solve this inequality. Okay, negative 3x plus 5 is greater than negative 7. I can do here. So we have a negative 3x plus 5. You solve negative 3x plus 5 is greater than negative 7. Okay. So how do you solve this? Exactly. Subtract 5 from both sides because you want to isolate x, right? So you subtract 5 from both sides. You subtract 5 from both sides. You cross them out, right? So now it would be what? Negative 3x is greater than, you combine negative 7 and negative 5.
Negative 12.
Yes. So this is negative 12. And then what to do?
Divide by negative 3.
Yes, yes. So now you see negative 3x. You told me divide by negative 3. Is that right?
Yes.
Okay, so this is negative 12 divided by negative 3. Now, we need to be a little bit careful here, okay? So we divide both sides of the inequality by negative 3, right? Negative number, right? So what will happen to the inequality sign?
No flip.
Yeah, you reverse it. That makes sense? Yes? You see that? Okay. So now this negative 3 and negative 3, you can cross them out. You can cancel them. So x is less than, what is negative 12 divided by negative 3? Negative 4, right? Yeah, you are right. So this is the solution. So any number less than 4. Any real number less than 4. There are infinitely many real numbers less than 4, right? You see what I'm talking, right? Satisfy this inequality. Okay. So now we have a interval which is very important. Let me see here. If you have an open interval, let's say that you have a set. This is the set builder notation for the set. Let's say you have a set of all x such that x is greater than a, right? And the interval notation, you guys know the number line. You see this is a number line, right? Number line. So this set is the set of all x such that x is greater than a. So you have a number a somewhere here. Let's say you have a right here. Okay? So you have, let's say your a is right here. Does that make sense? And this set consists of the values of x, all x, so that x is greater than a. Right? The values of x greater than a lie to the right of a. So here, this. Did you say that? Here. But it does not include a. This set does not contain a because x is strictly greater than a. Does that make sense? So if the interval does not contain a, then we use the parentheses. You know what I mean? This parenthesis means a is not included. That makes sense? This is the convention. You know, convention is if you have a parenthesis a, comma, and the value of x goes all the way up to, it goes all the way to the far right. Is that right? So that means to the far right, we have a number, but we don't know what that number is, which is undefined, right? So we represent that number by infinity. And this is the notation for infinity. You see what I'm talking, right? So always keep in mind this a parenthesis a comma infinity, right? It represent this inequality x is greater than a. Okay, and so yeah, I think like I made it clear. Did you get it? So now you see this positive infinity, and then the infinity. If you start with negative infinity, you put parentheses. So that you start or close with infinity, then you always put the what? Parenthesis. This infinity is, it does not actually represent a number. You know what I mean? It's the, to the far right of A, there is a number which is undefined in a sense that, hey, what is the number here? Like different people come up with what? Different answer. You know what I mean? So that means undefined. That makes sense? So this. And then let's say if you have a set of all x so that x is greater or equal to a. Now this set also consists of what? A. A is included here, right? X is greater than or equal to a. So if you include a, you have to put bracket. So now this is the number line, right? You have a here, and x is greater than or equal to a. So that means all values of x to the right of a, like this. And it also include a, because x is greater than or equal to a. Does that make sense? So now we have to put bracket. And the notation is, the interval notation for this is you put a bracket a comma, and you have infinity. When you close infinity, use parentheses. Okay? Does that make sense? So now if you have a set, let's say your set is set of all x such that a is less than x is less than b, you can graph on the number line. So let's say this is a number line, right? And then you have a here and you have a b here, and you see the x is between a and b, right? X is greater than a but less than b. Is that right? Did you see that? A is less than x is less than b. Right? So this region. Are you with me? This one, okay. Okay. The black shaded region. And then this is a strict inequality. The end points is not included. So that's why you have to put the what? Parentheses. That makes sense? Right? So the interval notation is this. So this is equivalent with a is less than x is less than b. And then if you have a let's say state of all x so that a is less than or equal to x is less than or equal to b, so now the end points are included because x is greater or equal to a, right? And x is less than or equal to b. Does that make sense? So now if you draw the number line and you have a here and you have a b here, and you see this is a is less than or equal to x is less than or equal to b, you include the end point. So that means you put the what? Bracket. That makes sense? And now this is equivalent with what? A is less than or equal to x is less than or equal to b. Right? Are you with me? This. And then the third one is if you have a, let's say the state is state of all x such that x is less than b, something like that. If you want to graph it, you have a number line, your b is somewhere here, and the value of x is less than b, and it does not include b. You see that? So less than b. The right end point b is not included, so you have to put a parenthesis here. Sorry. Are you guys with me? Parenthesis, right? And then this region, these values of x represent this set. Okay? And then now to the far left, you have a very, very big negative number which is undefined, right? So we denote it by what? Do you know that? Negative infinity. And if you start with negative infinity, you put parentheses. If you close with positive infinity, put parentheses, okay? Comma, b, and the b is not included. The right end point is not included. Is that right? So that means you put the what? Parentheses. Make sense? And this is equivalent with x is less than b. Now if you have a set, let's say set of all x so that x is less than or equal to b, the right end point b is included. See that? So that means if you draw the number line, you have this the number line and you have a b here and b is included. But all the values of x to the left of b. So to the left, this. Make sense, guys? And now, so this is negative infinity, comma b, b is included, so put bracket. So this is equivalent with x is less than or equal to b. You got it? Right? And then, now look here, guys. Are you guys with me? Look here. If you have a is less than, look here, if a is less than x is less than or equal to b. So this is called semi-closed interval. The interval is closed on the right side, but it is open on the left side. Okay? You see that? X is strictly greater than a, right? Right? And it is less than or equal to b. So now you see a is less than x, so you have to put parentheses here, you see? You put parentheses here, and you do something like this, and this is this. Did you see that? Huh? If your set is, let's say, set of all x such that a is less than or equal to x is less than b, the value of x is between a and b, it also include what? A. Is that right? But does not include b, which x is less than b. So if you want to draw the number line, so you have a here, you have a b here. B is not included, you put parenthesis. A is included, you put bracket, right? And then all these values of x here, these values, see that? These values of x, right? So now a is less or equal to x is less than b. This is equivalent with. So these two intervals are called semi-open, or you can say semi-closed, right? One side closed, one side is open, right? Okay. And then we have a and then we have a disjoint interval. So let's say you have a set of all x. So this is the disjoint interval. It's a set of all x so that x is less than a or x is greater than b. Okay? So now, if you want to draw the number line, then what will happen? So you have a number line here, a is here, and b is here, right? So x is less than a, So let us plot the graph for this inequality. Okay, less than a is this region. Okay, guys? See that? Right? And then greater than b, so greater than b is right here. And this or, so that means union, okay? So how do you write that? Do you know how to write that? To the far left, we have a one-defined number negative infinity, is that right? All the way up to what? A, but a is not included, so you put the parenthesis. Are you with me? And this or means what? Union, right? Right? And then what will be here? Exact, b comma infinity. Make sense? Does that make sense? And then let's say this one is less or equal to, and this one is greater or equal to. So that means a is included, and here b is also included, right? So now how do you write that? Negative infinity comma a is included, so put bracket. Union, b is included, right? So you put what? Bracket, b comma infinity. Make sense? And then if you have so that means this, Okay, so how do you, hey, by the way, if you have a set of all x so that x is a real number, like this, you have a set of all x such that x is a real number. Set of all x such that x is a real number. If you have this, so you see x is a real number, so this is a real line. You know what I mean? Set of all x such that x is a real number. Every real number is represented by your point on the what? Real line. So that means this is just like a negative infinity comma what? Positive infinity. So this is the set of all real numbers. Make sense? Yes? Okay. So let's solve this inequality, okay? And we have to give the solution set in interval notation. So these are the interval notation. This, you know, these are the interval notations. So we want to solve 4 minus 3x is less than or equal to 7 plus 2x. The idea is pretty much similar. You know, the solving linear inequality is kind of similar to the what? Solving linear equation. The only difference is if you multiply or divide both sides of the inequality by a negative number, you have to reverse the what? Inequality sign. Okay? So now you group the x terms, okay? So what do you want to do? You want to group x terms on the left side. If you want to do that, you move 2x to the left side. Okay? Are you with me? So you subtract 2x from both sides. Good? Then what will happen? This positive 2x and negative 2x, you can cross them out, right? And then it will be what? 4 minus, what is negative 3x minus 2x? 4 minus negative 5x is less or equal to 7. Then you isolate x term, right? So that means you have to move this to the right side. So you subtract 4 from both sides and you cross them out. So that would be negative 5x is less or equal to, what is 7 minus 4? 3. You got it? And then you need to have the coefficient of x 1, right? But here you have the coefficient of negative 5. You have to get rid of negative 5. How is it possible?
You divide by negative 5, or you divide 3 by negative 5.
Yes. Now, you said you divide both sides by negative 5. Is that right? Now, what will happen to the inequality sign? Yep, you flip it. So it's greater or equal. Be very careful here, okay? And now you see negative 5 on the top and negative 5 on the bottom. You can cross them out, right? So we will end up with what? X is greater or equal to negative 3 over 5. Make sense? So x is greater or equal to negative 3 over 5. Now, but you need to write the answer in interval notation. Interval notation, okay? So now, this is the number line. So negative 3 over 5. So this is 0. Let's write 0 on the middle of the number line. Negative 3 over 5 is a little bit, you know, it lies to the left of 0. So let's say negative 3 over 5 is right here, okay? This is negative 3 over 5. Are you guys with me? And the value of x is greater or equal to negative 3 over 5. So greater or equal to, that means negative 3 over 5 is also in a solution set, right? It is included. So if it is included, you put the what? Bracket, right? And greater than negative 3 over 5 means it lies, the values of x lies to the right of negative 3 over 5. Agree? Right? So bracket, negative 3 over 5, comma, what will be here? Infinity. This is the answer. This is the final answer. This is the interval notation, okay? Okay. We got it, right? Make sense, guys? Okay. Now, can you read this problem? So you see that your revenue and the cost of a certain product are given by R equal to 4x and C equal to 2x plus 1,000. So where X is the number of units produced and sold. At what production level does R at least equal to C? So now, look here, guy. So the revenue function R, so this is the revenue, okay? Revenue, we denote by R, is given by 4x. And the cost is denoted by C, is equal to 2x plus 1,000. Okay? Now, and this X is the what? Number of units produced. X is the number of units produced. So R is the revenue function, right? Revenue for a revenue of a certain product, and C is the cost, right? And so these are the revenue and the cost function, and X is the number of units produced and sold also. So the question is, at what production level? So that means the value of X is what, right? When the revenue is at least equal to C. R is when R is at least equal C. Are you guys with me? So at least. So what is the inequality sign for at least? Yes, greater than or equal to. So this is same as R is, right, greater than or equal to C. Make sense? So what is your R? You plug in the value of R. Okay, what R function, your revenue function is 4x, right? R equal to 4x. So you can plug in 4x for R is greater or equal to, your cost function is 2x plus 1,000. Make sense? Then you need to find the what? The value of X, right? So you subtract 2x from both sides. Are you guys with me? So you subtract 2x from both sides. You cross them out. So 4x minus 2x is 2x is greater or equal to 1,000. So you see, you divide both sides by 2. You divide both sides by 2. So that will give you X is greater or equal to what? 500, yeah. This is 1,000, okay. I missed 1 0 here. Okay? So this is X is greater or equal to 500. So that means, so the revenue function is at least equal to C. So that means the revenue is greater than or equal to C when the number of units produced and sold is greater than or equal to what? 500. Does that make sense? Yeah. And then the interval notation for this one is, you see, you have a number line, this is a number line, and this is a, let's say you have a 500 here, X is greater or equal to 500, so you put the bracket here, is that right? And this region. So that is 500 all the way up to positive infinity. And the break even, right, is the point where the revenue equal to what? Cost function. So that means the profit is 0. If the revenue equal to cost, at that time you will have a 0 profit. Profit equal to 0. Does that make sense? And the value of X is called the what? Break even point. And in this case, the break even point is 500. If the number of units produced and sold is 500, at that time the revenue will be equal to cost. Profit will be 0. Right? Okay, so now, hey, this is the three-part inequality. You see that? Oh, sorry. So, you have a three-part inequality, okay? Three-part inequality. Solve -2 is less than 5 plus 3x is less than 20. Now, how did you solve this, guys? So, look here. So you have the left side, middle side, and the right side, right? And you have an x on the middle side, right? So you need to isolate x. Does that make sense? So now you see we have a 5 plus 3x here, right? So how do you isolate x here?
You would subtract 5.
Yep. But if you subtract 5, you need to subtract from all sides, okay? So you subtract 5 from here, you subtract 5 from here, and you subtract 5 from here. Make sense? And so what is -2 minus 5? -7 is less than this 5 cancel. This is 3x is less than, what is 20 minus 5? 15. And then you see the coefficient of x is 3, right? We have to make it 1. We have to make the coefficient of x 1, so how is it possible? Yeah. And then the nice thing is if you divide by positive number or if you multiply by positive number on both sides, or you don't have to change the inequality sign. That makes sense? But if you multiply or divide by negative number, you must flip the inequality sign. So it will be -7 over 3 is less than, this is x. Hey, what is 15 over 3? 5? Right? And then you see on a number line, so you have a -7 over 3 maybe somewhere here. You have a -7 over 3, and here positive 5, this region. See that? And then you have a strict inequality, less than, right? Are you guys with me? So you have to use the parenthesis. Okay? This is the solution for this inequality in interval notation. Make sense, guys? Now we will solve quadratic inequality. Okay? Look here. So, solve quadratic inequality. So, x squared minus x minus 12 less than 0. Okay? So, the first step is you find out the solution to the corresponding equation. So first you make this equation. The corresponding equation is, are you guys with me? This is the first step. Step 1, okay? You find out the corresponding equation, okay? So the corresponding equation, you know how to make an equation, right? You just replace inequality sign by equal sign, right? The corresponding equation is x squared minus x minus 12 equal to 0. Does that make sense? Then you solve it and get the values of x. And you know how to solve it, right? So what are the factors of x squared minus x minus 12? So what are the factors? So what are the factors of negative 12 so that the sum is negative 1? Negative 4 and negative 4, 3, comma 3, right? When you multiply, give you negative 12. When you add, give you negative 1. Makes sense? So the coefficient of x squared is 1, so you can simply write x minus 4 times x plus 3 equal to 0. Makes sense? So use the zero factor property, right? So that will give you x minus 4 equal to 0 or x plus 3 equal to 0. So the value of x is 4 or value of x is negative 3. Did you get it? Yes? Now step 2. You determine the intervals, okay, made by the solutions to this quadratic equation. So you see, you plot them on the number line. 4 is somewhere here. This is the point 4. And negative 3 is somewhere here. Are you guys with me? Huh? So you have to determine the intervals, okay, made by the what? Solutions to the quadratic equation. Okay? So now, what are the intervals, guys? How many intervals here? Negative infinity all the way up to negative 3. So let me write down here intervals. So you have a negative infinity all the way up to negative 3. Is that right? And what is the second intervals? Negative 3 all the way up to 4. Right? And what is the last one? 4 comma positive infinity. Are you guys with me? Yes? So what did I do? First, I found the corresponding what? Equations. Is that right? And then I solved the equations, right? And I got the values of x. And then I used those values of x to identify the intervals, right? And you see, I plotted them on the number line, and I got the intervals negative infinity, comma negative 3, negative 3, comma 4, and 4, comma positive infinity. You got it? Now we will take test value from each intervals. Okay? So now we'll pick test value from each intervals to determine whether to determine which interval is a solution set. Okay? So now, and you can pick any test value. You can pick any values from this interval as a test value. You can pick any point from this interval as a test value. But we need to be a little bit careful. You know what I mean? If we pick a number, right, a smaller number, right, then when we plug in here, the calculation will be what? Easier. So I can pick any number from this interval. So if I pick, let's say, negative 9,999, something like that, then I have to plug in here, right? And the calculation will be what? Huge. So from this interval, what values of x do you like to take as a test value? You pick any values from here. What do you want to pick? Negative 4. I will pick negative 4. I don't pick like a negative 99. You know what I mean? Because this negative 4, and then We will plug in this test value in this inequality, and we will see whether this test value satisfies this inequality or not. So the question is x squared minus x minus 12 this true or false? So this is the question we have to answer. Okay? So that means we will plug in this test value in this inequality, okay? So we will plug in this test value in this inequality. Let me show you here. Okay? Are you guys with me? We have this interval. We pick a test value. You can pick any value, right? But we will pick such values of xij test value that makes our computation, that makes our calculation easy enough. That makes sense? So now we picked -4. You can pick -5. Doesn't matter. You know what I mean? You can pick -6. You can pick -1000. Because those values lie in this interval -∞, -3. Right? But your smart choice is what? -4. Does that make sense? So now, you have the inequality x squared minus x minus 12 is less than 0. Your test value is -4. You plug in test value here, okay? So now if I plug in -4 here, this is -4, parenthesis -4 square. Are you guys with me? Minus your x is -4 minus 12 is less than 0, question mark. I'm just checking. Makes sense? Okay, what is parenthesis -4 square? 16. Yes. So this is 16 and this is plus 4, negative times -4, positive 4, minus 12, less than 0, question mark. Right? So what is 16 plus 4? 20 minus 1? 19 less than 0. Is this true or false? Is 19 less than 0? Yes.
How can you write down a -1 instead of -12?
Oh, this is true. I missed that part. Yeah. I missed like this part. Thank you for pointing out that. Okay. Very nice catch. Okay. So 16 plus 4 is 20 minus 12 is less than 0. And what is 20 minus 12? 8. 8 is less than 0. Is this true or false? It is false. Is that right? Right? So this is false. Makes sense? So that means this interval is not a solution to the given inequality. Make sense? Now let me repeat the same process for this interval. Okay. So what do you wanna pick as a test value? You cannot pick -3 because -3 is not in the what interval? Because this is, you see the parenthesis here, right?
Wouldn't you be able to do 1?
You can do 1. You can do 1. But you see, as long as the interval contains 0, it's better to take 0 as a what? Test value. You see what I'm talking? You can pick 1, you know what I mean? You can. But if you have a 0 on the interval, it's better to pick 0 because it will be very easy to play with 0. Is that right? So now this 0, and then you plug in 0 in this inequality. Now you have a 0 square minus 0 minus 12 is less than 0. You have a question mark, right? So this is just -12 is less than 0. Are you with me? Right? Hey, -12 less than 0, is it true or false? True. So this is true. So now this is a solution set to the given inequality. Okay? So now let's do the similar thing for this one. Okay? So what do you want to pick for the test? What do you want to pick as a test value? 5. And then you plug in here. So this is 5 square minus 5 minus 12 is less than 0. So you know the 5 square is 25, right? Minus this 17 is less than 0, right? So what is 25 minus 17? Yeah. 8 is less than 0. Is this true or false?
False.
This is false. So this is also false. And now you say it cannot be a solution, right? So you see the solution set to this inequality is -3, 4. Does that make sense? So this is the final answer. Are you guys with me? That makes sense? Now, let's say for example, okay, if you have a non-strict inequality like this, you see what I'm talking, right? You have a non-strict inequality like this, less than or equal to. At that time, the solution set will be what? You have to include the end point also. So you have to write down -3, 4, and you have to enclosed with the brackets. You have to start with the bracket, and you have to enclosed with the brackets. That makes sense? Okay. So this is this, and I think you can, it's pretty much same thing here, guys. Is 2x squared plus 5x minus 12 is greater or equal to 0. We follow the similar process, okay? We follow the similar process. And now, so you see, it's pretty much the same thing, you know. Now, we will talk about rational inequality, okay? So these are the steps we need to follow, you know, like when we are going to solve a rational inequality. The first one is rewrite the inequality if necessary so that 0 is on one side and there is a single fraction on the other side. So look here. If this is a rational inequality we are going to solve, so rational inequality. And you have a 5 over x plus 4 is greater or equal to 1. And you see the step 1, you make 0 on one side of the inequality. Okay? So you see we have 1 on the right side. We have a rational expression 5 over x plus 4 on the left side. So we want to make right side 0, okay? So how can you make right side 0? Subtract 1 from both sides. Okay, so it would be 5 over x plus 4 minus 1 is greater or equal to 0. You see, we are done with the step 1. Does that make sense? And what is the step 2? So, and then, oh, by the way, we are not done with the step 1 because we have to make a single fraction on the left side. We do not have a single fraction on the left side, right? We have to make a single fraction on the left side. So now to make a single fraction on the left side, you see this is x plus 4 as a denominator. So I want to make the denominator x plus 4 here. So that means we need to multiply top and bottom by what? X plus 4. What I'm trying to do, I am trying to make a single fraction on the left side. And how is it possible? I want to make common denominators, right? What is the denominator of the first term? X over 4. I want to make the denominator x plus 4 on the second term, okay? So how is it possible? I multiply denominator and numerator of the second term, right, by x plus 4. So it would be 5 over x plus 4 minus x plus 4 over x plus 4. Are you guys with me? Because 1 times, right, this is negative here. Are you with me? Okay. So now, you see we have a common denominator x plus 4. We have a common denominator x plus 4. And in the numerator, we have a 5 minus parenthesis x plus 4 is greater or equal to 0. Okay? So now you simplify this. So this is 5 minus, you distribute this negative, okay? So negative x, and negative times positive is negative 4 over x plus 4 is greater or equal to 0. So this will be 5 minus 4 is 1 minus x over x plus 4 is greater or equal to 0. Does that make sense? You see that? Now we need to determine the values of x that makes the numerator 0, right? And we need to also determine the value of x that makes the denominator 0. Are you guys with me? We need to find out, we need to determine the value of x that makes the numerator 0, right? And we need to also determine the values of x that makes the denominator 0. Okay? Are you with me? So what values of x makes the numerator 0? To find the value of x that makes the numerator 0, we have to set numerator equal to 0. That makes sense? And solve for x. So what is the value of x? 1. Is that right? Right? So are you guys with me? So what value of x makes the numerator 0? 1. And to find the value of x, right, that makes the denominator 0, you set denominator equal to 0. What is your denominator? X plus 4 equal to 0. And you solve for x. So what is the value of x? Negative 4. So you see that, right? 1 makes the numerator 0, and negative 4 makes the denominator 0. Okay? So use these values of x, right? Use these values of x to determine the intervals, okay, on the number line. So you use these values of x. So you have a number line here, and if you want to plot them to determine the intervals, right? So x equal to 1. So let's say here you have 1, and here you have a negative 4. Are you guys with me? Right? So far so good? So what are the intervals, guys? Can you identify the intervals determined by negative 4 and positive 1? The first interval is to the far left. We have a negative infinity, is that right? So what will be the first interval? Yes, negative infinity, comma negative 4. What will be the second interval? Negative 4, comma 1. What will be the third one?
1,
Yes. 1 comma positive infinity. Right? And then we have to pick test values, and then we have to answer the questions. Is 5 over x plus 4 greater or equal to 1 true or false? So this is the question we have to answer. Make sense, guys? Yeah? So now, hey, what do you wanna pick as a test value? Oh, okay. What's that?
-5.
-5, yes. Right? -5 lies on this interval, right? So now you plug in -5 in this inequality, okay? So let me work over here, okay? So this is my inequality. 5 over x plus 4 is greater or equal to 1. I want to test for the value of x equal to -5. I want to plug in -5 here. So 5 over -5 plus 1 is greater or equal to 1. Question mark. Okay? So now you see here, so this is -5 over, what is -5 plus 1? -4 is greater or equal to 1. Right? That makes sense? So now what is -5 over -4? It is 5 over 4, right? Right? It's greater or equal to 1. What do you think? Is this true or false? You see the 5 over 4 is, this is 1.25, is that right? Right? Then definitely 1.25 is greater or equal to what? 1. This is true. Are you guys with me? Yes? Yes? Did you see that? I plug in -5, so 5 over -5 plus 1. Oh, sorry, I made a mistake here. Oh, this is 4, right? You see that? This is -5 plus 4. What is -5 plus 4? This is -1. What is -5 over -1? Yes, this is 5 over 1. So 5 over 1 is simply 5. Is that right? Right? And this is 5 is greater or equal to 1. Why did I put -5 here? It doesn't make sense to me. I messed up. Look here. I'll show you again. Okay, I don't know how did I do that. Like I just put -5 here. So anyway, so this is our original inequality, right? 5 over x plus 4 is greater or equal to 1. Is that right? What is our test value? -5. And I want to plug in -5 here, okay? I want to plug in -5 here. So this is 5 over, the value of x is -5 plus 4 is greater or equal to 1. There is a question mark. Okay? And then, look here. This 5 over, what is -5 plus 4? -1 is greater or equal to 1. Question mark. What is 5 over -1? -5. -5 is greater or equal to 1. Is this true or false? False. Okay? Did you get it now? Good. So this is false. This is not a solution. This interval is not a solution set. Right? Did you get it? So now the next one, okay, -4, 1. So what do you want to pick as a test value? 0. So now you answer this question. So your original inequality is 5 over x plus 4 is greater or equal to 1. You plug in x equal to 0, right? So that is 5 over 0 plus 4 is greater or equal to 1. So this is 5 over 4 is greater or equal to 1. So what is 5 over 4? 1.25 is greater or equal to 1. Is it true or false?
True.
True. So this is true. This is a solution, right? That makes sense? Now, what do you want to pick? What test value we will choose from? We will pick from here? 2. Now, your original inequality is 5 over x plus 4 is greater or equal to 1. You plug in x equal to 2, so 5 over 2 plus 4. Are you guys with me? I plug in x equal to 2, right? Right? Greater or equal to 1. And now this is going to be what? 5 over 6 is greater or equal to 1. What do you think? Is it true or false?
False.
It's false. So this is false. So it cannot be a solution. That makes sense? So now, we got negative 4 comma 1. Is that right? Right? Negative 4 comma. Now you got to be a little bit careful here. Look at the inequality. What is your inequality? Your inequality is 5 over x plus 4 is greater or equal to 1. Is that right? Right? This is a non-strict inequality. Is that right? This is a non-strict, right? Now, if I include negative 4 in the solution set, if I include negative 4 on the solution set, what will happen here? That will make a denominator 0. Is that right? You see what I'm talking? So if I include this, it will be this. 5 over 0 is greater or equal to 1. What is 5 over 0? What is something over 0? This is undefined. Okay? The division by 0 is not allowed, is not permitted, is not allowed. Does that make sense? So now this is undefined. So that's why you have to exclude this negative 4 from the solution set. However, this is a non-strict inequality, right? But this is a rational inequality. You have to find the values of x that makes the denominator 0, and you have to exclude that value of x from the solution set. Are you guys with me? So that's why, however, this is a non-strict inequality, right? We are not going to include negative 4 in our solution set because negative 4 makes the denominator 0 and our rational inequality will be undefined. Is that right? So that's why you exclude. That means we have to put parentheses. Does that make sense? Right? But we will include 1 because, you know, like 1, we will include 1 because 1 does not make any problem here, right? That makes sense? Yes. So this is a solution. Did that make sense? You see why I exclude this negative 4, right? From the solution set. That makes sense, guys? Okay. So now this is the, you see, this is what we did here. You see that? Yeah. Yep. You look at the slide here. So the solution set is negative 4 comma. The solution set is negative 4 comma 1. Now similarly you can do this. You know what I mean? So you just make one side 0. You subtract 5 from both sides, right? Like look here, they subtract 5 from both sides, and they will make the denominator 0. You'll see that. They multiply denominator and numerator by 3x plus 4, right? And you see, and they just like calculation and try to find the values of x. That makes the denominator 0. Okay, now I want to stop here, guys. I will see you next week, Tuesday, right?